don't really need to see me on the screen here, do we? Better not hide it so well that I can't find it back to. Okay. All right, so this is part 2 of the surface area to volume / thermoregulation lab. This lab will have a lab report component due, and I put the due date on Blackboard, and I'm not gonna, we can look it up after we're done with the video, but I'm not gonna put a due date on this video because if someone from another class watches it, they may get confused if they have a slightly different due date or something. So, but it's due on Blackboard there, and it's going to be a lot like a Bio 1 lab report. In fact, if you noticed in your lab manual, the instructions are pretty similar to the Bio 1 lab report instructions. So there's an Appendix A that starts on page 40 that talks about how to do figure captions and things. And then there is a Appendix B lab reports section that begins on page 43. And it has the intro and what goes in each section, etc. I will point out, I was noticing 1 or 2 things that you might want to just circle or change. Well, one little one under materials and methods, it says EG, which means for example, Carafit 202 and then like an apostrophe. I meant that to say 2021, but I have a typo there. It says 2022 apostrophe or whatever. So you can change that to 2021 under materials and methods on page 44. And the other thing you might want to note to self on is that the example book citation on page 45 for the textbook, Uri, Wasserman, and all of that, that's for the old edition, the other version of the textbook that we stopped using last semester in Bio 2. We switched to the new book. So the textbook is not cited, cited there is not your textbook, but there is an example of your textbook's citations on page 47. Where I have an example lab report. That example lab report, your reports do not have to be in a double column format like that. That's just how I have had students write them that way. If you like that format, I have a template that will do it automatically. I can email it to you, but yours does not have to be done in that double column format. But that's just an example lab report there on page 47. And then on page 48 and 49, is an example rubric, how lab reports are assessed. Okay. All right, so a few basic requirements, and some of these may be slightly different than in the handout or in the manual, but it's not very far off here. In the manual, I think I say font size 11. I probably won't know the difference if it's 11 or 12, to be honest. If it was like between 10 and 12, that's more noticeable, but just aim for the default size of probably 12 times New Roman font. You can use 1.5 inch spacing. You don't have to do double. It's just a little easier to read than single spacing. And we're looking for 2 pages, no longer than that for the lab report. That includes your figure. You don't have to make your figure huge. If your figure can be shrunk, not so tiny I can't see it, but you can shrink it down a bit if you need to. But kind of like the one on the example lab report there. I'm going to ask for at least 1 primary source. That means a journal article. But of course, you can also cite that grasshopper one that I've already given you as a second one if you want. And your textbook should probably be cited as well, because that's where you can get information on. There's a whole chunk in your textbook about thermoregulation, including like evaporation and conduction and convection and all that. And you can cite, if you talk about any of that in your paper, you can cite your book as to where you got that information. Now you're going to have your name, a title, and then your name. I want you to put your lab partner's name as well after your name. Yours is first. And then also give me the day and time of lab, because when we're grading these on Blackboard, sometimes Blackboard will jump and I'll suddenly have like I'm trying to grade Monday's stuff and it'll jump to Thursday's stuff for whatever reason. And I'll catch it if it says Thursday lab on top, but if not, I might just go, I don't remember that student's name. Oh, well, I'll just keep grading. And then I'm like, oh, I graded the wrong lab. So it'll help us to keep on track. Okay, so these reports are to be done individually. So today, of course, you work together to collect the data to talk about what's going on. But individual writing is what we need to do. I recommend the third person passive voice, which sometimes is a little awkward for some students, but it's how not all science is written this way, but it's kind of the traditional way of doing it. So basically, rather than say we did this or I did that, it's often said like, instead of saying I added 5 milliliters of water to the beaker, you would say 5 milliliters of water was added to the beaker, right? So it's just written from that perspective. And then if I add anything that's, I say, make sure to do this, and it's not in the manual, just jot it down, or, if I say, make a point of this, especially, I have that on there because there's more than Professor Carey for teaching this course, and somebody might want something a little bit different than the way it's written down. Okay, so introduction. I have a big triangle on this slide for a reason. The introduction starts broad and then gets more specific to your experiment as you get to the end. Okay, so by broad, I mean from like an all of biology perspective. Like I might not know what your exact experiment was or what you thought it was going to happen or anything like that till the end of your hypothesis. So the beginning is an introduction. It's like a pre-lab. Like, right, how like last time we met, I was like, here's what thermoregulation is, and here's how organisms thermoregulate, that kind of information. So you're going to assume that the reader who's reading the paper may not be an expert in thermoregulation. You need some background for them. Introduce the topic. And there'll probably be citations there, like thermoregulation is this or that. You can cite your textbook or a paper there. Like, where'd you get that information? What was the organism, or in this case, probably the model organism that you tested? And then you could also say what it represented. Like we used copper pipes to model a lizard in a desert environment, something like whatever it was you did, that could come up. And then after all that, you'll have your hypothesis. So you have to have enough background information there that when you write your hypothesis, it makes sense to the reader, right? So you go from broad to more specific. And I just put a screenshot of the intro from the example here, which is actually a Bio 1 experiment that I kind of reworked a bit to be slightly more Bio 2-ish, but I thought you'd recognize the beat paper, right? Those of you who I think most of you took Bio 1 here. So I have an example of that. Okay, now the next section is one that students sometimes lose points for no great reason other than maybe they misunderstood what a materials and methods section is. So the first bullet point there says this should be in narrative form. That means it's not a bulleted list of ingredients and steps. It's a paragraph. Okay. This is where you would literally say a heat lamp was placed 5 centimeters above a clay ball that was this big around and weighed this much, or that kind of information. You want it to be in paragraph form, like I have here. Beets were cored with a 3 millimeter cork board. Cords were then sliced 5 millimeters thick, and discs were rinsed. Beet discs were then incubated at 25 to 60 degrees. Blah 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 blah. And so that is where you explain it well enough that the reader could replicate it, and hopefully you even tell them how you analyze the data as well. What did you do when you were done here and you were playing with the numbers? How did you check to see if things were significant or not? You could say a one-tail test or a two-tail t-test. That kind of information is important to the reader as well. So you'll want to have that kind of information in there. And make sure to do metric units, because sometimes I'll get like heat lamps were placed 6 inches from the clay ball, and it's like, it's science class, let's use the metric system, please. So keep that in mind. And if you Haven't taken any measurements. Hopefully you can set up your experiment the same way you did last time. But there is a scale that you're get out another one if you need it. And we have yardsticks with just bear in mind that there is a metric side to them, and there's a standard side to them. All right, the results. Another way that students sometimes miss a lot of points is they'll just put a graph here and move on, or a figure, I should say. But there is a paragraph involved, a written paragraph where you describe what happened. You don't explain what happened, you just describe what happened, like, oh, there was a 28% increase in this over that. And then if you notice any qualitative stuff, you can tell me that. But you want to include percent change or fold change, meaning if one column is above the other, you say, oh, well, the flat copper pipe had a 38% larger, 30% larger increase in heat gain than the round copper pipe, or whatever. You would quantify that difference. Make sure to put what the p-value is there, and put the actual number, not don't just say it was less than 0.05 there. Actually give the p-value there in the written section. And once again, don't interpret why the data happened, just say what happened. And make sure to reference the figure. That's when you say, there was a 38% increase of this over that, in parentheses, then figure 1, which tells the reader, hey, look at figure 1 to see this on the graph. You'll also include your figure, typically under the written paragraph. It should have the proper labels on the axes and error bars. Remember, there is an example in the manual if you forget. The caption should have all the required items like quantification of change, just like you had up here, sample size, error bar statement, which is the SE, remember mean plus and minus SE stuff, and the p-value. Now in the caption, you could just say p equals less than 0.05 or p equals greater than 0.05 if you want. If you have like a p-value that's like 0.00000322221, and you're like, how do I write all that? You could just, say it was less than that. Because sometimes you get a p-value that's like 0.3 times 10 to the negative fifth or something, and and I wouldn't mind seeing that up here, but you can just put, hey, it was less than 0.05 in the caption in that case. My suggestion is put your figure under the written results. And if you need to, because if you're running out of space, you can make the caption size 10 font instead of 12. And one other thing you can do, if you need to, is you can make your materials and methods at previous section size 10 if you need to save a little space. Some papers, well, real scientific papers do that for a few parts. They'll shrink the size slightly for a few things. All right, so we've told the reader background, and we've told them what we think might happen, and kind of what we did. Then we told them in detail what we did and how they might do it themselves. Then we told them what happened. Now is when we put all that together and make sense of what happened, the discussion section, or you can call it the conclusion section. So this one goes from specific to broad, meaning you start with my hypothesis was or was not supported. And then you might explain that a little bit. Don't just say it was or wasn't and then go, like, well, what do you mean? Why? Explain. Then using those concepts from your introduction. So when you did the introduction, you had to give background. And you had to pick what background was important for the reader to know to understand your paper. So this is where you take that background and your data and you make sense of your data. You say, here's why this column was taller than this column. This is what happened. There was more surface area to volume ratio here, therefore, or this one was this color and this one was this color, therefore this one reflected light differently. Whatever it is, you want to explain what happened. And this is also where if you are certain there were errors, don't just say there were errors, say how they specifically affected your data. But here's the important thing. Students love to say, I just know from grading, oh, we made an error, and they spend their whole discussion just talking about how they screwed up. And then it's like, well, that's not really a discussion section. Like, tell me how you think it affected the data, but then move on. And you know, if the experiment was a total disaster, you could say we would expect to see this to happen and tell why, you know, or something like that, rather than focusing on what didn't work. Now, importantly, we want to relate our findings. You know, we explain why things happened, and you can relate it back to the real world, the biological world. Like, so this is similar to how the, I don't know, pygmy rattlesnakes does this, you know, catches energy by laying on rocks, or this is similar to how snakes do that, or lizards do this. You know, why is it relevant? How is that copper pipe laying on a bench inside of the Conway Corporation for Science? How does that help us to maybe understand the natural world a little better, tie it back to biology, you know, bring it back home, and then providing a concluding, provide a concluding statement. Provide a concluding statement, like a sentence or so that kind of wraps it all up. And if you're a little bit short and you want to say a little more, I didn't put it as a requirement here, but you can also talk about in the concluding area, like what you might do if you were going to come back and further your knowledge on this subject. You could say, well, if I were to do this again, I would try doing it this way. I would ask this different question. I would approach it differently, or I want to expand my knowledge by doing this experiment next. You know, you can do that there as well. But I would prefer the last thing you say at the end there, just to make it easy to find, will be your final concluding statement. Like, so we have seen that surface area or color or whatever it is you did had this effect on thermoregulation, period, right? So that way it's easy to see that. All right, citations. When you're citing in your paper, first of all, we never quote from a book or paper. We don't pull direct quotes. We paraphrase. We take the knowledge from these sources, put it into our head, then use that knowledge to explain things that we're talking about, and we put the citation where we got that knowledge, okay? Rather than saying, here's a paragraph I copied from someone's paper. I don't know what it means, but there it is. You know, that's not what we do. So if it's just one author, you might have a sentence and where some of that information is given, and one author you might cite like this, Desord 2020. That's the year the paper came out, right? If you read a paper by Dr. Desord from 2020 and it had information, that's how you might cite it. If there were two authors on that paper, you use both their last names. Whichever author is first on the paper, their name goes first. That if you are first author on a paper, that means you're the one who gets the most credit for that paper. So it's kind of a thing, like a recognition of which author did the most work. So their name goes first on the paper. So Desord and Hurley. So sometimes you might say, well, it's D and H, so the D goes first. I know I did this and got points off on the first lab report I wrote. Probably that's why I'm pointing this out. So if it was like Desord and Abrams, it would still be Desord and Abrams, even though Abrams starts with an A. That's the order of the authors on the paper, okay? And if there's three or more authors, you say Desord et al., which is Latin for and the others. Now, this is what you do in the text part of your paper, not the lit cited part at the end. This is how you would cite a sentence in your paper, where you want to point out where you got that knowledge. For example, here's that paper that I have posted on Blackboard, that grasshopper paper. Ectotherms can control, I have a typo there because I was typing this up and so it looks like crap right now, but let me just read what I wanted to say. Ectotherms can control their body temperature by adjusting their posture relative to a heat source. Whitman, 1987. So I didn't pull that line out of Whitman 87. I was like, oh, cool, grasshoppers can do this and stand different ways to the light and control their body temperature. And I'm pointing out that fact and where I saw information on that. Then the lit cited section at the end of your paper is where you give full detail on that paper so someone could find it if they wanted to. And the format we use, I have an example here from my thesis, actually, just so you can kind of see there. We use a hanging indent, which means the first line sticks out more than the other line, so that makes it easy to tell where one begins and one ends. And these are in alphabetical order by the first author. Once again, like if I had Desord and Hurley, that would appear down here under the D's somewhere. You know, I only have down to B here on this example, but you know, that's not that you're going to have that many. By all means, you're going to have like 2 or 3, but you know what I mean. They'll be in alphabetical order based on the first author. The way we typically do this, or the way I'm asking you to do it, and there is an example in the manual, but you have the last name of the first author, their initials. Then if there's other authors, you know, comma, their last name and their initials, for example. The title of the article, the title, and that's usually italicized, the title of the journal, the volume number, and then the page numbers. So for example, here's one with a bunch of authors, the year it was published, the title, the journal name, the volume number 90, and then page, then there's a colon there, and then the page numbers. So now the reader knows which journal to go to, which volume, where the page numbers are, what the title is, and who wrote it. So it's real easy for someone to track all that down. So that's what we're looking for in the literature cited section. So you'll have probably your textbook cited there. I'm not going to require that you cite the lab packet or manual unless you think there's something that needs cited out of there. You don't have to do that. But the textbook and at least one primary source. But you could also cite that Whitman et al. Because I have that posted for you already. So you could use that one too. It doesn't count as the one that I want you to find, but it can be a source of information to help you write your paper. So your grade will ultimately reflect the quality of your work and the clarity of your writing. If you have all this stuff there, but it's hard as heck to read it, you're not going to get the grade you would have gotten if it was clearly written, concisely written. So scientific writing is clear and concise. So if you need to remind yourself what that kind of writing looks like, have a look at that Whitman paper I posted on Blackboard, that example grasshopper paper, or go back to that piranha paper that we looked at in Bio 1. That's a great example of scientific writing. It's nice and short, clean, concise. So I recommend that piranha paper as an example. If you don't have it anymore, I think there's a link to it on the Bio 1 website yet, under like the scientific writing link. If your differences are not significant, don't just say nothing happened, I'm done, I don't have to do any interpretation. Well, probably one of those columns is still taller than the other. We call that a trend. It's not significant, but it's a trend. You can still talk about what the trend was and what it might show, even though we can't conclude it definitely shows. It might still be hinting that with further refinement of our experiment, this is what it's trying to tell us, right? And lastly, this is the heartbreaking part, is sometimes one lab partner will do a great job, and then the other lab partner is like, can I see what you wrote so I can make sure my paper is good, which really means, can I copy your crap and not tell you about it? And then I get 2 papers that are like the same, except this one says there was a big increase, and this one says there was a massive increase, you know, that kind of difference. And it's like, and then, of course, one lab partner is shocked that someone cheated off of them, and the other one's like, yeah, it's like, well, okay. So let's avoid that, please. I don't want to have to give zeros on a big project. This one's 75 points, if I remember correctly. And we don't want to, that's almost an exam grade, so we don't want to get a 0 on something like that. All right, any questions on the lab report stuff? Yes.
Okay, so last semester we had to go like to the writing center. Do we have to do that?
You do not have to go to the writing center, but I highly recommend it if you feel that you know, it'd be nice to have someone look over your paper with you. The writing center is available with online appointments and things. I'm not making it a mandatory requirement for Bio 2, but it's a resource that's available to you for any of your writings all the way till you graduate. So that's something you definitely can do. Anything else? Should I stop the recording? Did anyone watch this?
All right.